Predicting precipitate formation with a QSP. Okay, what was the KSP in the previous video? Okay, the link is in the description. It's used to find the product of the concentrations of maximum amount, okay, that can remain in the solution. That means it can readily dissolve. It's not gonna get to a point where it kind of builds up and is a leftover amount and precipitates to the bottom of the beaker. Now, what is this Q? Okay, in this QSP, it's the reaction quotient, also known as the trial ion product. Trial means that's what we get in the data that we actually got and collected, or what we see in the practice problems, which we're going to be looking at later on in this video. This is useful to predict if the precipitate will or will not form. So for example, if the QSP that we get is greater than the KSP, okay, the KSP is this gold standard of maximum amount that can remain in the solution, okay? So then the precipitate will form, okay, because it is now supersaturated. It's gone past this threshold of the KSP gold standard, okay? If the QSP ends up becoming equal to the KSP, the precipitate will not form because it is technically saturated. However, it's at the tipping point. Anything greater of the QSP that we have that even goes a little bit above this threshold of the KSP, then it's obviously going to become greater than it, and a precipitate will form. Okay, if the QSP is less than the KSP, the precipitate will not form because it is undersaturated. Now in this question over here, we have to find if a precipitate forms. Okay, will the precipitate form as AgCl or NaNO3? Because we're missing this and this one together, right? So we're going to get NaNO3 together or Ag and Cl together. Which one? We're going to have to deal with the AgCl, because as you can see in this chart here, which will be given to you from a teacher, okay, before an assessment, okay, this NaNO3 is ending with a nitrate. All nitrates are going to be soluble. There are no exceptions. So the only way a precipitate can form is with AgCl. So we're going to be looking for AgCl. So we're just getting this Ag from this AgNO3, and we're getting the Cl from this NaCl. Okay, so all of these are the given ones. Okay, we just have to find our moles. After you do that, you just keep bringing them down, and you have to find a new volume, okay, to divide by, because we're just adding these two different volumes together into the same beaker. So that's 1 liter, 1 liter. You add them up, you divide them. Now you have a new concentration. Now the QSP has the same formula as the KSP. It's just a multiplication of the products, okay, so just like the KSP. So you end up getting this, multiply this, you get this value over here. Now how about the KSP? Okay, the KSP is not always going to be given to you. Again, same thing from the chart. Okay, you're going to be given a chart from a teacher before an assessment. As you can see, we found the AgCl's KSP. It's over here. Okay, so we're just going to compare this QSP with this KSP value. Which one ends up becoming bigger? Obviously the QSP is going to be greater, and therefore precipitate will form. So these are the two green questions of the day. Please try these on your own, and I'll be giving you the answer shortly. This is the answer to the first question. This is the answer to the second question.